This session is going to be about making generative AI enterprise ready and making your enterprise GenAI ready. So basically, just to level set everyone, we distinguish between predictive and generative AI. Predictive AI we've been doing, in the same way we've been doing numeric AI. NLP evolved into generative AI, basically giving us the ability to create conversation, etc. We have now moved to embeddings and different types of enterprise search, semantic search, etc., and code generation. So today what we're going to be talking about is very briefly looking at how to make generative AI enterprise ready, issues around data quality and governance, model bias, explainability, security, privacy, scalability, and performance. And then on the other hand, making an enterprise, an organization, GenAI ready in terms of data infrastructure, best practices and patterns, talents, upskilling, etc. One of the key things we're going to talk about today is this business value checklist that you can take to your customers or yourselves within your organization and determine whether you can derive business value from GenAI. How can you generate business value from GenAI? Pun intended. You first have to de-risk that decision path, understand what the pitfalls are and the issues, and then be able to take a path. But once you're down a path, you should be able to pivot and deal with the ramifications of that path. And then decide whether you want to maintain course or be able to change course. So you need a platform that allows you to do that essentially. And so some of these key considerations for generative AI are summarized in these 5 aspects for business, 5 aspects for the technical side. We're going to jump in. The first one is around responsible AI. We very strongly believe in responsible AI. And what that means is when you send a model, an LLM, a request, a prompt, you get back a result. But the result, when you send it to some of our POM, some of the Google LLMs, you get safety attributes back. So it tells you whether these things are, how harmful, how obnoxious, etc. they are. And you can threshold on them. If you're building an R-rated application or you're building a PG-rated application, you can make a decision and move forward on that. The other is we provide a content moderation API, because if you send garbage into the language model, guess what you're going to get? And so we also need to be careful about what tooling we have for bias detection and balancing. And that's part of the issues around governance and evaluation of your data to determine how much biased it is or not as it goes into training. So there are additional considerations with responsible AI, the ethical implications, regulatory landscape, and the impact of GenAI on the workforce. And some of the issues that we encounter, the biggest challenges. So I'm going to ask you folks, what are your biggest challenges in making generative AI enterprise ready? Any takers? I'm sure you're all in some shape or form thinking or implementing GenAI for your organization. Because if an organization doesn't employ some form of response to the GenAI revolution, then what are we doing, right? Our lunch will be eaten by a competitor. So any suggestions? What are your biggest challenges? Any takers? Yes?
Making GenAI responses be more deterministic and not change so much.
Making it more deterministic, not making it change so much in production. Thank you.
Robust to adversarial outputs.
Robust to adversarial outputs. Awesome.
Data privacy.
Data privacy.
Yeah.
Excellent.
General access security.
Access security. Okay. Accessing models, accessing the data, the code that you generate. Yes, sir.
Leveraging anything outside your security perimeter to take the access back.
Ah, okay.
Sending what you're getting back.
Yes. Making sure the security perimeter is actually secure when you go outside of it and come back. Exactly. So these are some of the tough challenges. And so therefore, privacy and security. One of the key things, and that was a planted question, by the way, my friend. I'm kidding. It wasn't. But this is a response to what excellent point you're mentioning, which is when you're looking at a secure and private set of things, things meaning models, data, code, that you need to manage, in your perimeter, in your cloud perimeter, you need to make sure your content remains secure and isn't leaked. If you're building a conversational agent, if you're building some kind of search capability, if you're fine-tuning your models in any shape or form, you don't want your data to end up somewhere else, your code to end up somewhere else, or your models to end up leaked. So in terms of the Google Cloud perimeter, these things are within the perimeter and are safe. If you're making a call to the LLM, it is through an encrypted pipe going back and forth, and there's zero retention policy. Nothing is saved, you're not going to be trained on that. In fact, when you want to tune a model, when you want to train some additional customization into the model, using a variety of the techniques that we have, adapter tuning or low-rank adaptation, we bring the model weights to your platform, to your actual perimeter, your project, and then train there. And as a result of that, you don't have any leakage. Your model isn't even going to the central hosting area. Everything is completely secure. And the weights of the model that you just trained or fine-tuned are then stored in your cloud storage, those model weights. And at inference time, the same thing are loaded from your cloud storage. And these can be under customer-managed encryption key. So you can hold the key, the secure key, to do so. In terms of cost, prices are out there. There's a whole bunch of price drops. Everybody's dropping prices left and right. Check them out. That's kind of, a moot point. All right, domain specificity. This is one of my big points. So in order to access models, so we're going to have a whole lot of models. And those models you need to fail fast in the training or tuning of models. And in order to do so, we provide you with the ability to tune these domain-specific models. So if you go on the platform and you decide to, let's say, train a medical diagnostics data set, just with the inputs and outputs of symptoms and a classification of what is the actual diagnosis. You can create a model, and that model is a fine-tuned version. This is not fully fine-tuned. It's an adapter-tuned model or a low-rank adaptation-based model that is then sitting in your model registry. There's a pipeline that's automatically generated for you. It's deployed and as a Vertex endpoint, and you can hit that endpoint. So if you ask your model something, you want to get a very specific answer. This is a model, if you notice up here, this is the model that I trained, and I'm getting a very specific answer. When you ask these LLMs these types of things, LLMs usually ramble. They say, you know what, I'm so sorry you're feeling bad. You actually should go see a doctor. Don't talk to me. I may not even know. You're just saying, please, just do a classification. I just want to move on. This could be a job description. This could be a skills description. This could be a financial services mapping to a portfolio. It could be a simple classification task. You don't want the model to ramble on. So tuning provides you, one of the things that it does is it provides you with focus on the downstream task and in terms of the output you want. So you're able to tune these models. In terms of price, I always call these lemonade models. Why did I call them lemonade? It costs $9 if I were going to pay out of my pocket to tune one of these models. So they're extremely low barrier entry kind of exploratory things that you can do. This was 1,000 rows of training. Okay, so the next point, apologies for the acceleration here. I'm on 1.25x. If we were on YouTube and you're listening to someone, that's the speed I'm at. If you want, you can reconfigure me and I'll go back to 1. So in terms of org culture, we want to make an enterprise generative AI ready. So you need to talk about data infrastructure, model deployment, development, talent and skills, and organizational culture. There's a whole bunch of things that I have for you. The last one, the leveraging the patterns and best practices. I actually like you guys so much. I wrote a blog for you that I'll give you at the end, which describes in detail everything that I haven't said, because you can't fit it within 30 minutes. But you do want to see some cool stuff, so I'll show you what that is in a QR code. You can look at it. The flip side of the coin is that you want to make generative AI that you're using, not only the enterprise generative AI ready, but your generative AI enterprise ready. It's super important to have that bidirectional maturity. And there's a whole lot of things that we need to be talking about, which we're beginning to get into in terms of data quality, model bias and fairness, explainability, security, privacy, scalability. But I'm going to touch on, these are the obvious ones. I'm going to touch on the less obvious ones. Of course, as we mentioned, your data, your model, and your code is private and your own when you're utilizing these capabilities. The other thing is the tools you want to use, you want to have them across a spectrum where if you don't have much ML knowledge, you can use stuff out of the box. And if you do have machine learning knowledge, you want to actually be able to leverage that knowledge and tune a model. You really get into changing, reconfiguring something so that you can leverage your expertise for that model. So that's that spectrum. Now, really, really important from a skills perspective is that we all really understand this spectrum of customization of models, because it's going to come in handy for you. There was a point where everybody was coming to us and saying, we want our own pre-trained models. Really? You want your own factory to build cars? That's great. Maybe you can afford it, and if you can, that's great. But maybe you want to try with tuning models first. So it's important to understand the distinction and for us to communicate that distinction to stakeholders in terms of the difference between pre-training, fine-tuning, up-training, prompt tuning, and things like parameter-efficient fine-tuning. And its variations, its various flavors of parameter-efficient fine-tuning, like adapter tuning and low-rank adaptation. So the blog I mentioned to you talks about this thing. I'm discussing it in terms of a bunch of verbs, like prompted is the first one. Well, obviously, we all know that. That's trivial, so let's move on. The in-context learning aspect, the ICL aspect is there as well. A lot of people add these various types of chain of thought, tree of thought, graph of thought type of notions, depending on how much you want to automate the process. If you want a chain of thought, you just break the process into steps. If you want a tree of thought, you have a tree structure which can programmatically influence the next step. And if you have a graph of thought, it's just more complicated. So details and papers are all there. The other verb is to RAG it. Everybody knows about retrieval augmented generation. There's another flavor of retrieval augmented generation called FLAIR, which is almost like a look ahead. In what you do in retrieval augmented generation is the language model was trained, let's say, 4 months ago. I'm asking it, trivial example, I'm asking it for, hey, can you give me an itinerary for a bike ride today in San Francisco? It says, what are you talking about? I don't know the name. I don't know where you're at. I don't know where you're at. You're saying San Francisco, but you want a bike trip for you. What is the temperature? I have no clue. You have to give me this stuff. So retrieval augmented retrieves data. Go to an API, get the weather, get the location, get the coordinates, give it to the model, and now the model, prior to in that same context window, you're providing it to the model to do something. A lot of people say it decreases hallucination. Yeah, maybe it decreases hallucination. That's correct, because it's now supposedly knowing something it completely was oblivious to. But the point is, please be careful. The data has to be current. Otherwise, the model will just lie. It won't hallucinate, it'll lie, which means that at some point in time, the weather was this, but it's no longer the case. So that data has to be current when you're retrieving it. It's super important from a governance perspective. So sometimes when you do this look ahead, the FLAIR, it says, hey, I'm going to look ahead, and I know you're going to gather this data. Is this data valid for today? Is this valid for your question today? So using variations of retrieval augmented generation is important to explore, such as FLAIR, which will allow you to have that forward-looking vision. So you're anticipating an answer and then looking it up, seeing if it's okay, looking at the possibilities, versus just retrieving and just passing it to that magic box we call the LLM. The other aspect is to tune the model. And tuning it, as I talked about earlier, super, super important because you want to change the output format. You want to slightly teach it a little bit of new things. If the model knew how to dance and knew 4 dances, you're just teaching it another dance. You're not completely teaching it how to play soccer, right? So you're not, for that, you need full fine-tuning in order to achieve completely different sets of knowledge-based tasks. But the tuning requires preparation, and the prep part requires you to have at least, if not supervised learning, at least input-output pairs that are clean data, that are representative of the distribution that you want in order to provide the model to tune it. The other aspect is once you actually get a result, before you send it back to your helpless, hapless user, you need to actually go and see if it's grounded. Go use the grounding mechanism that your service provides. In this case, Google, we provide grounding services. Well, grounding service is very simple. You do a search and see if you can get results that are commensurate with whatever the language model is telling you. So you're comparing those two and determining whether you can ground it in reality. Is there a citation for it? Is it an actual paper on archive, or is it something that it made up? So you actually go out and search, and you couple that with the output. You compare that with the output. That is the grounding capability. There's another mechanism that is called REACT, which is reasoning and action. It's basically a planning mechanism. It says, I want to plan the course of, it's almost like you're trying to prove a theorem, but not to get mathematical. Basically, you're trying to plan a set of tasks. You're trying to plan a project. And those steps in the project have dependencies with one another. REACT helps you gather information and reason about what the next steps should be and take action based on where you are today. If the project is slipping, you can't go to the next phase. You have to either throw resources at it. Bad idea, actually, according to Fred Brooks. Sorry, that was a complete hallucination. I'm going to backtrack on that one and do a grounding and make sure that if a project is going awry, you don't throw people at it. So correction there, sorry. And finally, you basically make sure that everything goes back through a responsible layer so that the security, the privacy, the zero retention is all in play as you give it back to as a safe and vetted, grounded output. So this is the storyline. We need to know that these things exist and checklist them as an enterprise application. It's no longer just the fun and games of, okay, I'm going to go to Bard and ask for whatever. You're going to go and build an application that's going to be impactful for the business. So some of these vertical tooling capabilities are going to be extremely important. Part of these are where we're about here. Ray and Anyscale are very good Google partners. And Ray gives us the ability to do distributed parallel computation of various scales and sizes. And that's one of the ways in which you can start training and tuning and delivering infrastructure. And typically what you can do is you can either create new products and services or increase the performance and optimization of the existing products and services you have. In some cases, you can actually build completely new business models. But you need a platform on which to run this. And so the horizontal ML lifecycle support needs to be there. On Google Cloud, this is just the generative aspect there. So you see Vertex AI is the name of our kind of the umbrella set of capabilities that we have. We have a set of AI agents. We have search and conversation capabilities out of the box. And then the AI platform itself. At the heart of that is the model garden, where you have open source models like Falcon, which I really like, Llama 2, which is not really open source, but kind of permissively licensed. And then, of course, our own first-party models, which we've pioneered in terms of Palm 2, its various flavors and sizes. Text Bison, we have t-shirt sizes of models. We like to call them animal names, like gecko and bison and unicorn and things like that. And then ultimately, we have the capabilities in the model garden for third-party models, our partners, companies like AI21 Labs, Anthropic, Cohere, et cetera. And of course, the ML ops capabilities, the responsible AI tooling capabilities that I talked about already are there as well. So this, in and of itself, comprises the platform on which you're building an enterprise scale beyond the gimmicks, beyond the let's try and have some fun with generative AI. If you want to build, industrial scale applications, these are the kinds of things you need. Now, the next generation of platforms must take into account, you notice here that we have the model garden, which comprises of about 100 models that we've offered through the model garden. They comprise foundation models, task-specific models, and open source models, like I mentioned. And these models allow you to also perform computation on the ML platform in terms of incorporating open source frameworks. So, in fact, we like Ray so much that we've built Ray on Vertex AI. So there's a preview that we announced at Next, our conference a couple of weeks ago. So you can actually spin up Vertex AI and run Ray right there natively on Vertex. And this allows you to the only change is here, you just specify the Vertex Ray capability in Ray init, and the rest of it is whatever you would do as usual. It's a low-friction way that Ray users can use their existing code out of the box, and new users can basically run the same paradigm, but on a platform that is a scalable platform, such as the Google Cloud Platform. In terms of open source Ray, by the way, I have a talk at 3 o'clock where I'm going to go into the nitty-gritty technical details of making Ray enterprise scale. I'm not talking about Ray on Vertex. It's just open source. How do you take Ray the open source, and actually make it enterprise ready? That's at 3 o'clock. I'm not going to talk about it now. But there are a whole bunch of things you do in open source Ray that Ray on Vertex just does for you right off the bat that you can access. And so there's native integration with Colab Enterprise, with Vertex AI training, with the model registry in Vertex AI, and with prediction, with inferencing. And there's integration with BigQuery and logging, and more to come. So we're very excited about Ray on Vertex as well. And so if you look at the Colab really quickly, I promise I won't go into too much detail here. Basically, all you need to do is basically specify the number of clusters. You just add this Vertex Ray capability to the Ray init and add it to the runtime environment. And then you just go and do whatever you need to do, as you've always done with Ray. So nothing super special. It just gets rid of a lot of things that you would ordinarily have to do yourselves. It just does it for you. So that's kind of the upside of the Ray on Vertex AI. OK, so back to the story of the third technical aspect in terms of integration with backend enterprise systems. Retrieval augmented generation, you all know about. Now, I've kind of filled out this thing here. So the stuff I talked about earlier was more high level. This is a little bit more detailed. And you'll find the details of it in that blog that I put up for you. Basically, what we're saying is that, for example, for a RAG or some kind of a look ahead on retrieval augmented generation, you're doing vector embeddings and search. But remember that this is just for unstructured data. You can combine that with your normal SQL, or if you have a graph database, access the graph database, do a SQL and the vector search, combine them together in order to actually retrieve something and give it back to the language model. Super important to not just get caught up in, hey, I have a vector database. Everybody who has any data, anything, will have a vector database version. That's very natural evolution of what we're seeing. In terms of tuning and serving, you'll see a combination of foundation models, parameter efficient fine-tuning, and full fine-tuning capabilities there. So you can read all about this in this blog. No need to go into more detail. The other thing is this access to backend enterprise systems that's super important. you got to be able to access these older enterprise systems. When you want to make a GenAI enterprise ready, there has to be an integration with these backend systems. So for example, if you have these more canonical systems like SAP Ariba, like Salesforce, etc., you want to be able to tap into them and engage in a situation where I'm not going to go into it at this point because we don't have much time. I was going to show you a demo, but I won't. Instead, I'm just going to show you the architecture. The demo is just a conversational agent. It doesn't really show what's happening in the back end. All it's doing is basically trying to do a procurement. And in terms of that procurement, it's looking up something in the back end system. It's translating human language into SQL, generating code, going in the back end, going to another system to see if there is another vendor, another supplier, a new supplier, getting the prices for you, and then you can negotiate you can interrogate the contract, not negotiate, use the wrong word, interrogate the contract. You can ask the contract question, hey, it's a new supplier, can I ask it to do different things? And so you'll get responses back from what's happening in that contract, and then finally, through the conversational agent, you're interacting with these back-end legacy systems that are clunky and have these huge user interfaces that are not very intuitive. So having a conversational interface with it is extremely effective. And of course, we're doing all these things under the covers, the RAG, the grounding, etc. In terms of needing infrastructure, of course, you have all the infrastructure that you would need on the Google Cloud Platform. In terms of TPUs and GPUs, both, we announced a very strong partnership with NVIDIA at Next. And so we're partnering. NVIDIA's building their next generation DGX platform on Google Cloud. And then to unblock you for enterprise scale production workloads, there's a program that we have called Built with Google AI. So if you have companies or you are a company who would like to work with us, we have a program where we unblock you and enable you to succeed with these types of capabilities. And with that, we are a few minutes early, so time for questions, if you have any. Thank you. Yes?
So we talked about that security perimeter. So the base model still lies outside of the customer security perimeter.
Foundation model, yes, correct. But when the inference is happening, the weights are loaded in your capability.
But the data does go out.
The data does go out in a secure pipe and comes back with zero retention. So nobody sees the data. Did the tree fall in the forest? If you haven't been looking at it, I don't know. It's Schrodinger's cat. I have no idea. But yes, correct. Yeah. Because the alternative is you can host your own foundation model. You can build in host your own foundation model on the platform as well, if you wish. It's just very expensive, right? Any other questions? Yes, sir.
Does Google, you mentioned about the build with Google, does that allow companies to build out some infrastructure on their own data centers, or is it just to help them onboard their data to the Google Cloud?
This is to help you build on the Google platform. You leverage the Google platform to build your applications as an ISV. You could have your data elsewhere and just make calls to the foundation models, for example. You don't need to bring all your data, for example. Yeah. So those are various options that are available to you as an ISV.
Services that run
On-prem. We do have GDC Edge, and we have various capabilities, Google-hosted services, but it's primarily connected ultimately in the cloud. So there's a temporary air-gapped solution, let's say, for government or security types of scenarios and organizations. But then ultimately, Anthos, is the capability that we've announced for that capability. But the ultimate experience of using generative AI and predictive AI on your AI ML platform is ultimately on Google Cloud. That's where we can serve you better. All right, thank you very much.